Hello everyone. Once again I am Pulkit Gupta. I am here to teach you embedded C programming for 8051 microcontroller in some very simple and slow steps of different small practicals. In this video I will teach you about how to connect circuits of different interfacing practicals and will also explain C code for 8051 line by line. To set up the programming environment of 8051 microcontroller, you can log on to my blog pulkit.eu. There you will find step-by-step guide to set up, or if you don't find anything, then just email me. By the way, programming environment used is Keel Microvision 4 and FlashMagick software is used to burn your generated hex file into microcontroller. In my blog, apart from this, you will find several other projects including Git repository for all of them. You can also go to my YouTube channel to check some other videos of your interest. As this video is a quite long video, around 45 minutes, so a list of all practicals are given below in description. You can choose any practical of your choice by clicking there. So let's start with this 8051 microcontroller learning tutorial.
Hello everyone. So now we will discuss each and every component, external component which is to be interfaced by 8051 microcontroller. So first one practical, the simple one is the LED interfacing with 8051 microcontroller. Now we will discuss the circuit making first and then we will go to the programming part. LED interfacing via 8051. In 8051 we just need to make any D, that is digital or data pin, of any port of microcontroller, either high or low. High-low state means high means +5 and low means ground. Now this code is used to glow LED on the 0th pin of the port 1. Sorry, port 0. Because in this code segment we have P0 to the power, the sign of power and the 0, and is equal to 1 shows that we are giving high state to this pin. To make a circuit, first of all take a jumper. Connect jumper means with help of jumper connect P0 pin, the 0th pin of port 0 to LED pin. So now this pin is for this LED. Actually this LED is L7. So when you connect port 0, the 0th pin to the LED 7, it will glow because of default state 1 of the pin. Now comes the code for the glowing of LED with 8051. Mainly this is the simplest code for our 8051. So here I have done hash include register52.h, which is the register header file contains declaration of all the registers to be used in the program. S bit is used to take a identifier to make a identifier of desired pin. I have declared a function in it where I have parameter int x, but I am not using this function because this function is used in big programs, big codes where we have a large number of statements for initializing our project. After void main I have while 1. So this while 1 is used in every embedded program, because in embedded program we don't have any integer or any value to be returned to the operating system, because embedded system don't have any operating system. So while 1 is used so that our code can execute again and again in a cycle. Now in this while 1 we will have our actual coding from where the position from where our code will start. So LED is equal to 1 will glow our LED, which is the main feature, main task for this code. Hence this statement is main statement, which is responsible for the functioning of our 8051 microcontroller with LED. Now comes second practical, a little bit more advanced. It will have same circuit but different coding, because here the external component which was to be connected to 8051 is same, but the functioning of that device is different. So in previous case our LED was just being glowed by the 8051 microcontroller, but now in this case it will blink. So circuit is same. I have connected first pin of my port 0 to the LED 7. This is my port 0 and this is L7. Now come to the code. Again the same thing, hash include register 52.h. Here again as bit LED is equal to port 0, pin of port 0. Again we have not used this init function because this is used for initializing in projects where we have various initializing statements. Here there is new function delay, where delay has void return type and has one parameter unsigned int. In this I have declared two variables I and j which are used inside the function itself. These are local variables. You must have studied it in C language. So there in this for loop what I have done, I have taken two variables, two local variables I and j, and I have inputted them in two nested for loop. One for loop is this and another one is this. So first for loop is controlled by the external variable, but the second one is calibrated with help of a value. So here I have taken 110 as a calibrated value. You can check that by changing this value your delay time should be near 1 second when your s is equal to 1000. Now this is main function, while one is which I told you that embedded you have to use a infinite loop inside main function, otherwise the program will end. Now what is being done, delay is called. Now on calling of delay, our CPU cycle, the CPU of 8051 cycle is wasted till 1 second, the calibrated 1 second. After that LED is won, the LED is glowed by giving this identifier value 1. Again we have delay and then we have switched off that LED. So in this case between these 2 points our code is executed infinitely. So due to this code blinking pattern is seen. Now we will see that any LED connected with the 0th pin of port 0 will blink at the approximate interval of 1 second. Third practical is about port interfacing in 8051 microcontroller. As we know, in 8051 we have 4 ports, so I will show you how to interface those ports. I will show you interfacing port 0, and you can similarly interface any of the port of 8051 with the same code. Just you have to change the value after P keyword while declaring any macro. Now let's see how a port is to be connected to any other device to interface any device to the data pin. Data band, not pin, because a port contains 8 pins. So for making any circuit, now in this case we are just connecting 8 LEDs with our port 0. So for that take a band of 8 wires. Now this is the band which you have to take. take a band because we are gonna connect 8 LEDs with 8 pins of a particular port. Connect it like this. You can yeah, this side is connected to port 0 and this side is connected to your LED series. Now in blinking port, what we are going to do is we are blinking our 8 LED series with help of 8 parallel pins in our band. So but in this case we are not using any digital value, we are using hexadecimal value for interfacing any device connected to our port. Like here we have same thing, header file for our 8051. Now in this case I have used init function for some purpose, void init. Now I have removed parameter because I am not using any predefined value to be initialized at the starting. So port 0 is equal to 0x00. Now as you know that 0x is symbol for hexadecimal thing. So 00 means 4 binary 0 and 4 binary 0, total 8 zeros band. So by this command I have given all the wires connected to port 0 ground and hence all LEDs off. All LEDs off. White delay is another same as discussed previous. Now in void main init is called. So as init is called, at this stage I have given ground to all the pins of port 0. Now while 1 is used in embedded program, as I have told you. Now what I have done, delay, after delay on. Now let's see what exactly in on is being done. P0 is equal to 0xFF. So what is 0xFF? 0xFF, you must have known that F stands for 1111 in binary. This is hexadecimal, this is binary value. And what about decimal value, like 1 2 4 8? 15 is decimal value. So F stands for 41 and similarly this F stands for 41. So in binary we have a band of 8 1. So at this stage all the LEDs are on. Similarly again delay of 1 second calibrated with value of 110. After that port 0 is again given 0x00, which means 480. Now what exactly is happening, that between the 1 second delays, port 0's all pins are switching from 1 to 0 and 0 to 1. So in this way we get a blinking pattern on port 0 and our LEDs connected to that port blinks with an interval of 1 second. Now practical 4, input linear button. So to inputting 8051 microcontroller to give our controller signal from a button, we can use it in two ways. One is linear, that is simple and that can be distinguishable very well in coding. Another one is matrix, or where you use combination of different switches in rows and columns. So in linear input switch we make circuit as follows. Take two jumper wires. First of all connect one jumper on port 0 pin to LED 7 pin, because when we are pressing any switch, so we need to connect one more device to show the signal is going inside the 8051 microcontroller or not. Now take another jumper and that will be connected to This is 0 pin, this is 1, this is 2, and this is 3. So connect that pin into P03 pin and on switch 1 pin. So now at this case this switch is connected to our port 03 pin. So after these connections, let's come on to the coding part. This is header file. Now I have declared two different identifiers. One is switch and another one is LED. LED is pointed by port 00th pin and switch is coded with the pin port 03. In initial function I have given switch 1. Usually this is preferred that when you are using any device as an input device, either sensor or any switch, you have to initially give that pin 1, because a controller cannot source so much, but it can sink very good amount of current. So when your input is your signal comes, so at that state your pin should be 0, because that is the better condition, better state for a comfortable state for 8051 microcontroller. Now in delay function, delay will be same function, because this is a standard delay function made by the concept of wasting CPU cycles of approximately 1 second. In main function, the main thing is this: LED is equal to node switch. LED is equal to node switch. Now first of all, as in C language, right hand side is executed by the compiler. So switch, first of all 8051 will see the switch status, which is nothing but third pin of port 0. So if the status of that pin is 1, suppose at default state, so with help of this not is to revert the signal, the overall signal will become 0 and that will be transferred to LED. So at steady state, at default state, when someone has not pressed the switch, at that case LED will not glow. But if someone has pressed switch, this SWTCH will become 0, and after this operator it will become 1 and LED will be given 1. So LED will glow when we will press switch, otherwise it will not glow. Plus I have taken SWTH, not SWITCH, because this is a keyword in C language, so you cannot use this name as identifier. So this is a rule from C language, and you must follow C language rule, because language is the same but different library is being followed. Now comes toggling through switch. Now here the same circuit will be there, but little bit level of that practical is increased. Toggling means to change the state. So now a switch will change a state of any LED, anything connected to the microcontroller, another or external pin. So circuit is same as of switching LED. One jumper will connect LED with the port 00 pin, and another jumper will connect any of the desired switch to the third pin 0, 1, 2 and 3, third pin of your switch. Now this is code for toggling of our LED with help of switch. This code is little bit longer than the code which we had studied. It has same things: switch is declared, LED is declared, init function has switch is equal to 1, delay is same. Now comes the main logic. After a long time we have seen some logic in our while loop, infinite while loop. So let's see what exactly this logic is. Suppose we have taken a global variable, I, and initialize it to 0 at starting. In main function, init is called to make the input pins 1, or you can also put some statements which can off the LED at starting. While 1 is infinite loop, which is used in embedded, as I told you. After that, in while loop, for the coding part, for the logic part, we have 3 if statements. Now let's see what exactly these statements are doing. In these if statements, switch is compared to 0. Now what does this statement means that switch is equal to 0? Here I am comparing switch keyword to 0, that whether this identifier is 0 or 1. So physically when a switch is not pressed, so at that state, as we discussed, that the pin of 8051 microcontroller is equal to 1 as our scheme. So when we press this switch, we get signal is equal to 0. So at coding, we can check our pressed or unpressed status with help of this 0-1 logic. So if our switch is equal to 0, that means this switch is pressed. So now what we are doing, we are incrementing our variable I at every press of this switch. Now at every press, our switch will our variable I will get an increment in its value. After that, in next if statement, we are just checking the remainder of the division of I with 2 is 0 or not. So mainly this is a mathematical logic of checking a number to be even or odd. So if a number is even, then this statement will execute, or this statement will give 1 and this statement will execute. So if the number is even, then LED is equal to 1, and if the number is not even, that is odd, so at that state LED will not glow. So this is simple toggling code. The logic used was the even odd pattern of whole number that is used in this code, so that we can toggle anything around us by using any relay, any compatibility of electronic circuit. Now comes practical 6, that is buzzer interface. Buzzer is not a main component, but without this use of buzzer, our main projects can lack in various things. Or sometimes a buzzer itself can make a very good project and very good idea to be implemented by 8051. So let's see how buzzer is interfaced with 8051 microcontroller. Circuit making. First of all, take a buzzer. You can take any buzzer, but you should know the current value and the voltage needed by that buzzer. That's very important for usage of buzzer, because if your buzzer is has need of more current, but you are not providing that current, because 8051 does not give so much, cannot source a large amount of current. So at that state, you should have used any transistor or any other relay. So for that purpose, you should know about the current rating of your buzzer. So this buzzer is in front of you, has a good amount of current value, so it need more current amount, so you cannot use it directly with the 8051 microcontroller. So for this, you may use any transistor, or you can also use UL and IC given on your 8051 platform board. so you can use that IC to amplify the current signal given by your 8051 microcontroller. For circuit, take some jumpers. Take a jumper and connect the lastmost pin, that is your 12 volt, to the long pin, because that pin is positive. Take second jumper and connect it to the pin beside the 12 volts pin and connect it to the short leg. Take another jumper, connect it to the port 0 pin and connect the 0th pin of port 0 to the input side of ULNIC. So this was your complete circuit, where we have given signal from 0th pin of port 0 and connected a buzzer on the outer side of ULNIC. Now 8051 controller will just give the signal, and it is task of ULNIC to run that buzzer, to start that buzzer, because of the large demand of current of the buzzer. Now this is a code for your buzzer interfacing. The code for buzzer is very easy. You can say that it is just similar to our first practical code. In this practical we don't have any complexity in code, because here we just have one difference, that is S-bit buzzer is equal to P0 power 0 is used instead of your LED. So we have just given buzzer is equal to 1. This signal has gone to, suppose this is your 8051. Now this is your port 0. So this signal is just gone to ULN, where you have connected your buzzer. So in this case, when buzzer is 1 is executed, buzzer is equal to 1 is executed inside 8051, this signal goes as plus 5 volt to the ULN enable pin, and outside it, whenever inside input side of ULN is given 1, then the opposite side, the outside of ULN, is automatically turned to 0, and hence a potential difference of 12 volts is maintained across the buzzer, and buzzer start ringing. Now comes practical 7, where we will control our buzzer with a switch. So circuit making is the same till you connect your buzzer to ULN. Now from here, take another jumper and connect your port 0 pin to enable pin, and take another jumper wire for switch and connect the port 0 first pin, port 0 #1, to the desired switch you want to connect. Now here we have added buzzer is not equal to switch. As I told you that this is the common part for all the, means delay will be same. In it has both the statements, where buzzer is also given 0 at starting, and switch is also equal to 1, the input, and this is output. This is a very good practice to add all the initializing statement in init, because on reset you can have an actual state which is confirmed for our operation. These are our declaration part, the common declaration part. Now buzzer is not equal to switch is the same as LED is not equal to switch. Buzzer will only ring when your this switch is equal to 0, and the overall value will be given 1 to the buzzer. Here again electronic complexity is more than your code complexity, because we have our controller, microcontroller, ULN, switch and buzzer. First of all, switch gives input to the microcontroller. After that, microcontroller gives signal after processing to the ULN. Then ULN give a power signal, power supply to the buzzer to run it. So this is a whole cycle where starting from switch, microcontroller processes the signal coming from switch to the input port, input pin, and then it transfer this signal to the ULN IC, which again amplify the signal according to the ratage of buzzer or any other device connected to this. And encoding part, as I've already told you, that between these two braces we have this code where buzzer is equated to the node switch, so it means that whenever switch is pressed, buzzer will ring. Now practical 8, run DC motor. For to make circuit of DC motor with 8051 microcontroller, let's proceed the following visual photographs. Take a DC motor, connect it like this. This is DC motor jack. You have to connect it like this, such that the left pin will be the positive, and this one is negative, positive and negative. Connect inside input side of ULN to port 0 0 pin. So by using jumper, connect this pin with this pin. Let's study the code. Motor is identified here with help of S bit, single bit initialization with port 0 first pin. In init function we have initialized motor such that the motor will not move on reset. Delay function is as usual. Init is called at starting in void main, and while one the main where the main logic code is there, then where motor is equal to 1. So in while one infinite loop we have motor is equal to 1, which means that this code, when this code will run and will reach this portion of infinite looping, then in this case controller will check that motor identifier should be 1, and that in turn is equal to first pin of port 0, which is connected to ULN enable pin, and that in turn will drive our motor. So this was very easy code just to begin with the motors, the concept of motors and ULN IC. Practical 9 is about switching motor. circuit for this is take a DC motor, connect motor to first two pins of ULN. Again, positive should be negative, the extreme side should be positive and the ground should be the outmost and 7th enable. Connect input side of ULN to port 0 first pin. Now here take another jumper and connect port 0 has one pin to the controlling switch, the switch you want, either this or any desired switch, which will be controlling switch for your motor. And in code you need to initialize both the input and output unit of your microcontroller. So here motor is equal to 0 shows that motor is initialized and it will not run after reset, whereas switch is equal to 1 shows us the basic schematic of giving 1 to the input pins, and it is called at first after the void main entry. In logic area it's written motor is equal to not switch, which shows that if switch is pressed then motor will run. So switch should be 0 if we want motor identifier is equal to 1. So because we have used not sign which invert the signal coming from switch, so in this case and switch is equal to 0 only if it is pressed. So this was all about the logic to run DC motor with help of switch. LED 7 segment with 8051 practical chain. First of all we need to connect 7 segment data pins to any of our ports. So I have used 8 wire band to connect 7 segment to port 0. Now this code is regarding 0 to 9 display code, where 0 to 9 counting will be displayed on 7 segment. Let's study the code. These all are the standard code which will come during when you will start your new project in Keel. This is delay function. I will tell you what is main thing in delay, why this function is too long. Yeah, delay, in this delay function we have this portion out commented. So here it's written that uncomment these if you want a great response for your switch. Now if whenever in any project if you are using any switch and that has any function and you need fast response for that switch, then you can add the switch name, the number of switch you can add with the help of OR is equal to 0. So whenever your switch is pressed it will break from your delay function and it will come out to the main function for processing of your switch. Next is another declaration for your 7 segment display, single bit A, single bit B, single bit C from 0 to 6. Now why init? A dynamic initializer function is defined and integer x is parameter. So this parameter is given to the init function and mainly the function of this init is to give the particular value 1 or 0 to the A to G identifiers of 7 segment. We have also void display, but in this currently we are not using this function, but void display is used to display, to give a combination of different segments so that we can display a particular number. So it has used switch statement in this. Switch is on the basis of int n. So when suppose 0 is entered, so in case 0, init 1 and g is equal to 0. So init 1 means that suppose this is a 7 segment LED, A, B, C, D, E, F and G. So init 1 means all the A to F, A to G is given 1, instead G is given 0. So G is explicitly given 0, so we get something like this showing 0. When display is given 0, then on 7 segment we get 0 as displayed. Similarly, case 2, case 3, case 4 are done. So from till here we have our all the cases till case 9. After that, in void main, before this we have taken an integer n and initialized it to 0. This is again a code which is by default will come with your integrated development environment, or you need not to do this explicitly. Now comes, first of all, we initialized to all the segment to 0 because we don't want at starting any of the segment to be grown. In infinite loop we have display n to display the number, so at starting we will have 0 as display because we have int n is equal to 0 at starting. After that, with some delay, approximately 1 second, we have increment in n plus n, and n will become 1 now. It will check if n is equal to 10, otherwise it will continue and will display 1. Similarly 2, 3, 4, 5, 6, 7, 8, 9. Now when n is equal to 9, after the delay of 1 second, n will be incremented and it will be equal to 10. So this condition will be fulfilled, and due to this n will reinitialize to 0 and our cycle will be continued. After 9 it will be 0 and 10 1 and so on. So in this way we have printed 0 to 9 again and again at delay of 1 second on our 7 segment LED with help of 8051 microcontroller. So this was all of our 10 practicals with help of our 8051 platform board. So best of luck for your practicals. Goodbye.
Thanks for watching this video. If you like this video, you can subscribe to this channel. For more detail, keep checking my blog. All the links are given in the description below.